Hello and welcome to today's IWCS webinar. Now I'm pleased to turn the webinar over to Ed Vinton, your IWCS moderator. Ed, please go ahead.
Thank you, Connie. Our IWCS webinar series event is hosted by the International Cable and Connectivity Symposium. I am Ed Fenton, a cable industry advisor working with the IWCS team. As Connie said, if you have questions, please use the Q&A box on the bottom right of your screen to post a question anonymously. If you wish to contact the presenter or IWCS after the presentation, you will be given the contact points at the end of the webinar. Please note that IWCS does not distribute the presentation slides from either our conference sessions or these webinars. However, please feel free to contact the presenter directly, and they will respond individually to you. Today, we welcome Thibaut Lanoe, Senior Product Development Engineer, Superior Essex in Kennesaw, Georgia, USA, who will be presenting his paper on 4-pair power over Ethernet deployment, standards, performance, and challenge. Thibaut Lanoe is Senior Product Development Engineer at Superior Essex International, Communications Division for the premises copper cables. He holds a master's degree in optronics from the University of Paris, Sud-Ons. He has 11 years of experience in product development for the category communications cable industry. Thibaut, we welcome you to present at today's IWCS webinar series event.
Good morning, everyone. Today I'm going to present my technical paper, the 4-pair power over Ethernet deployment, standard, performance, and challenges. This paper is presented by Superior Essex International LP, Communications Division, and IWCS. So the deployment of 4-pair power over Ethernet up to 100 watts and over 4 pairs bring many concerns and topics such as standard, safety, transmission performance over the category cables, and also energy efficiency of the cable installation, and also regarding the lifetime of the cable installation. So many topics are brought by this the 4-pair power over Ethernet deployment. Cable manufacturer and cable installers know that the category cables deployed for the 4-pair power over Ethernet have main requirements, such as to minimize the heat generation when the power is injected over the cable, to minimize also the power loss along the cable, to minimize the operating cost of the cable installation, and overall to guarantee the safety of the installation. Today, many standard committees have worked on this topic of the 4-pair power over Ethernet. The first one, the main one, and the most important one is probably the Hdpe 802.3bt, which is a standard committee which is going to define the power limitations, the communication rules, and also the compatibility between the active components on a power over Ethernet installation. We expect this standard to be released very soon, beginning of 2018. Another very important standard led by the TIA committee is the TSD 184A, which provides the guidelines for the installation of the category cables or balanced twisted pair cables, which is going to carry the power which is going to be deployed for the 4-pair power over Ethernet. And this standard has been released in the beginning of this year. UL also has worked on the 4-pair PoE, and UL deliver a limited power cable certification, which relates the maximum current traveling through the cable, through the pair, through the conductor, without exceeding the maximum UL temperature rating of the cable. That's also a very important standard, which has been released beginning of this year. And finally, we received also this year in 2017 an update of the National Electric Code, NEC, with the NFPA 17. The first thing that we can notice between all these standards, it's a possible confusion for for the installers, for the cable installers. Let me explain you that. Right now, the IEEE 802.3bt specify a maximum electrical current per pair of 960 milliamps. And the TSB 184A recommends actually maximum electrical current of 1 amp per pair, which is pretty similar value, but there is still a small discrepancy here. On another side, the UL 444 and the UL organization, with their limited power certification, allow the maximum electrical current to go up to 2 amp per pair, so 1 amp per conductor, without exceeding the UL temperature rating. So we think that can create some confusion, knowing that the POS system will be defined up to 1 amp per pair maximum, and adding some communication with a certification going up to 2 amps. So that's the first confusion. I want to remind everybody that the IEEE 802.3bt and the TIA TSB 184A refers to the international standard IEC 6950-1, which is a safety guidelines standard. And these IEC standards specifies that the power sourcing equipment is qualified as a limited power source, which means that we are allowed to inject or to work with a maximum of 100 watts per port with no overcurrent production device needed. And that's very important, because if we refer this 100 watts to a nominal 50 volt voltage installation, that refers to a 500 milliamp per conductor, so 1 amp per pair maximum. So that also supports the fact that there is some confusion here and some clarifications are needed. And moreover, I would say that these standards are mainly dealing with two main concerns today: the temperature rise along the cable, and the safety of the installation. But we think there is also a lack of explanation of rules regarding other concerns, such as the power efficiency of the cabling installation, which relates to the operating cost of the cabling installation, because if you spend more power, if you have more power dissipation and more power loss, it's going to increase your cost of electricity and the cost of functioning your cabling installation. And it's also another topic which is very important, is the lifetime of the cable components, which are exposed to high temperature. And that's what I'm going to try to describe today in this presentation. We know that the main consequences of injecting power up to 100 watts on category cables are, first, the generation of the heat by the Joule effect related to the DC resistance of the category cables. There is also, as I was talking, the voltage drop along the cable, generating the power loss, and also directly related to the DC resistance of the cable, of the conductors. And also the exposition of the cable components to high temperature, which is generated by the power loss and the heat through the cable. To study these requirements, we came up with an experimental setup, an experimental study with an in-house test setup We basically built a 100 cable bundle made of a 100-meter continuous length of cable. We placed these bundles on the stand, in the hair, in a controlled environmental chamber with an ambient temperature of 45 degrees C, which can be considered as a typical, the average temperature for the installation of these category cables. We applied 4-pair PoE on it, so 4-pair energized, 100 watts, 1 amp per pair with a 50 volt nominal voltage current, power on it. And we collected the data such as temperature, DC resistance, and also the power efficiency, which is typically the ratio of the power received over the power injected. We've selected a variety of cable specimens on the U.S. market, and we applied the experimental setup to all these cables. And as you can see on the list displayed right now, we picked cables from different categories, going from category 5E through 6 up to 6A, with different designs such as Hdpe, F/Hdpe, and different gauge from 26 gauge, 24 gauge, 23 gauge, 22 gauge. And we also picked, we wanted also to study some of these cables with copper-clad aluminum to see how they react when we implement them in a 4-pair PoE installation. So after running the experimental test setup through all these cables, we collected the data, and we looked at the power efficiency for a 100-meter cable at the maximum temperature measured in the center of the bundle. And the first thing that we can notice is that the two first cables with the copper-clad aluminum, the CCA cables, the two first ones, have a very poor power efficiency, and so it would be not very smart to implement them for a PoE installation, PoE deployment. What we can notice also pretty easily is that the cable which has the highest power efficiency, up to 88% power efficiency, it's a category 5E cable with a 22 gauge. And so from this set of data, we're going to come up with few comparisons and try to establish some rules and understand how PoE works regarding the power efficiency. So we came up with two main comparisons from this set of data. The first one is we compare the Cat5e Hdpe CMP 22 gauge versus the Cat6A, category 6A Hdpe CMP cable 23 gauge. Both of these cables have reached the same temperature rise, around 8.2, 8.5 degrees C over the 45 degrees C of the environment. And nevertheless, we can notice that the Cat5e Hdpe has a much higher power efficiency with 88% compared to the Cat6A Hdpe, which reach only 82.8%. We can say that the power efficiency is mainly related to the copper gauge of the cable and not the temperature, as these two cables have reached the same temperature level. But we can also say that Cat6A Hdpe has about 5 or 6 watts or 5 or 6% power to dissipate more than the Cat5e. And it seems that the heat dissipation is improved by the overall shield of the Hdpe Cat6A. In a second comparison, we looked at the Cat6A FUTP cable versus a Cat6A unshielded cable, UTP. And both of these cables have a similar construction. The power efficiency is very close for both of them, around 83%. And we can notice that the temperature rise of the Cat6A FUTP is much lower, with 8 degrees versus 11 degrees on the unshielded version. So it confirms our first comparison, saying that there is a better heat dissipation with an overall shield design with a FUTP design. We can say also, I need to notice that to you, that there is a slightly lower efficiency on the FUTP design with 82.8% versus 83.3%, despite the fact that both cables have the same gauge. Actually, when we looked at the dimension of the conductors on the FUTP design are slightly smaller, which also confirm our first comparison, saying that the power efficiency is directly related to the gauge, but mainly directly to the size of the conductors, to the DCR of the conductors. So in conclusion, regarding this first set of data, we can say easily that the overall aluminum shield definitively helped to dissipate the heat generated along the cable. We can also notice that a higher heat dissipation has not really a significant impact on the power efficiency. And actually, the gauge of the conductor and the DC resistance of the conductors remain the main leverages to achieve a high power efficiency. So related to the power efficiency, we came up with the operating cost of the system, or I would say the operating cost of a 100-meter cable placed in a 4-pair power over Ethernet system at 100 watts. So we did the summation over 20 years of the power consumption due to the cable by the power loss generated by the cable, by one cable, 100 meter, and we added the cost of the cable to it. And so we looked at the total cost of the installation for the 100-meter single cable over 20 years, power loss included. And we can easily see that the copper-clad aluminum cables are very expensive from an operating cost point of view. And the most cost-effective cable is definitively the Cat5e UTP CMP 22 gauge, which has a lower total cost compared to other cables. So based on this set of data, we were able to come up with some discussion points, such as it's pretty easily to say that the operating cost is related to the cable power efficiency. It's a nonsense, definitively a nonsense, to implement high DC resistance cables for 4-pair PoE deployment. It doesn't make sense. On the first approach, we could say that it's a low-cost cable, so it's cheaper. But over 20 years, or over the total life of the cable, of the cabling installation, the poor power efficiency of the cable rise the price of the operating cost due to the consumption of electricity. We can see that the category 5E with the 22 gauge is the most effective cable over 20 years, and it's a higher cost product. It's more expensive at the beginning, as is the 22 gauge. It's more copper. It's a richer product, I would say, but it's much more energy efficient. So over 20 years, over several years, we will save money and we will be more cost effective. So in conclusion, the cost of a 4-pair power over Ethernet cabling systems will be the right compromise between the cost of the cable design and also the power efficiency of the cable. In the second part of the study, as I mentioned earlier, we wanted to look at the impact of this high temperature on the cables, and what are the impacts of this high temperature on the aging and the degradation of the cable components, and especially regarding to the insulation materials for a long period of time. So over 20 years. 20 years, it will be the average lifetime of the cabling installation. So we ran a study to estimate the lifetime of the cable installation. And to pursue that, to do that, we basically based our approach on the oxidative induction time, or IT, which is a practical and common engineering and investigative approach, mainly used for OSP cables. So it's a pretty typical and known investigative approach in the cable industry. It's defined by ASTM standards. And this approach, OIT approach, will allow us to understand the impacts of high temperature on the insulation. And so we came up with an experimental study. First, we decided to focus on insulation components. Why? Because the insulation is located very close to the conductor. It's the closest component to the conductor. So it's the component which is going to be exposed to the most of the heat, directly to the heat, actually. We picked two specimens of cable, of insulation, and made of flame-retardant polyolefin insulations. And we focused on polyolefin insulation, and we verified also that the Hdpe, which is a high-temperature engineering material, is not sensitive to high temperature, the temperature of the POE that the POE can generate. So we really focused on the flame-retardant polyolefin insulations. We had some concerns and doubts about their service lifetime over 20 years. And so we basically estimated the service lifetime of the materials, of the insulation materials, at 40 degrees C, which is a typical environmental temperature, and 60 degrees C, which is the lowest UL temperature rating for platinum cable. And based on our OIT study, we came up with two conclusions, one for each sample. So the first sample meets actually the industry life expectancy over 20 years at 40 degrees C. So we didn't see any major degradation when the cable is used in an environmental temperature of 40 degrees C. But we have noticed insulation degradation at 60 degrees C with a lifetime expected less than 5 years, which raised many concerns about that. The second sample was even worse, I would say. It even didn't meet the life expectancy at 40 degrees C, and we have noticed very severe insulation degradation after 10 days at 120 degrees C, which bring many concerns about this kind of insulation on category cables, which can be implemented on a 4x4 over Ethernet system. So to conclude this OIT study and this estimated lifetime on the insulation material, we can certainly say that the polyolefin insulation have a risk to not meet the expected service lifetimes of the cabling installation. And that's a major concern. And we think that the industry needs to look at that. And to continue on this topic and to continue discussing this topic, we really wanted today to communicate on this concern to the cable manufacturing industry, because that's our responsibility to make sure that the cable we provide on the market are not going to jeopardize the expected service lifetime of the cabling installation. We definitively think that the OIT study that we perform is a quick, practical study in a limited time, and we definitively think that there is more to do. There is more detailed study needed to study the degradation of the insulation exposed to high temperature. And that also raises questions regarding other cable components, like cross web feeders, like jacket components. What happens to these components in the cable when they are exposed at high temperature, when the cable is deployed for 4-pair power over Ethernet up to 100 watts. So, as an overall conclusion of this presentation, first, we can say that the category cables implemented and dedicated to 4-pair power over Ethernet systems needs to maximize the power efficiency in order to reduce the operating cost over the lifetime of the cabling installation, and then also to guarantee the lifetime and the safety of the installation, and typically over minimum at least 20 years. We think that our study has highlighted many less understood areas of the 4-pair power over Ethernet cable design, such as the power efficiency and the impact on the cabling operating cost, and also the aging and the estimated lifetime of materials such as insulation. So we think as an overall conclusion that the cable industry needs to address this concern in order to guarantee the performance of the system and also to better serve the need of our customers. Thank you for your attention.
Thank you, Thibaut, for presenting this very, very interesting and important topic today.
Thank you.
At this point, we are going to take as many questions as time permits.
Sure.
That is starting with this first question. I heard that the new amperage table in the NEC actually has provisions for up to 400 W on a 4-pair cable. With Internet of Things and 5G on the horizon, are there cable designs that can handle this?
For now, it's difficult to answer this question, actually. I don't think that there is no one has conducted any study to look at up to 400 watts. Maybe some specific design could be done for that. I'm not aware about that. My vision is to say Hdpe 802.3bt is referring to international standards, IEC, which requires to stay under 100 watts. And so for now, what I will recommend is to stay under 100 watts until some studies, testing, and standards are made to support up to 400 watts or even higher than 100 watts.
Okay, thank you. Next question. You show the Cat 6A cable specimens with 23-gauge conductors. With Energized 4-pair cables, does the conductor need to be larger, for example, a 22-gauge?
Yeah, yes, it's possible, actually. It's exactly what I wanted to say during this presentation, that the power efficiency is directly related to the gauge of the conductor, to the size of the conductor. So if you want a category 6A cable dedicated for PoE deployment, so 100 watt PoE deployment, Definitively, I would recommend to use the Cat6A 22 gauge category cable because this cable will provide you a better power efficiency and it will lower the cost of your of the installation regarding the operating cost of your cable installation. So yes.
Okay. Next, what will the temperature rating requirements of the cable be for 100 watt, 200 watt, or 400 watt power over Ethernet cables be?
Again, I will not. I would rather not to answer that regarding over 100 watts. The Hdpe standard talks about 100 watts. We should stay on that. All category cables on the U.S. market have to go through UL listing, which defines the temperature rating of the cable, and it's recommended to also obtain a ULLP certification on the cables installed on the 4-pair PoE deployment. So I will, regarding the 200 watt, 400 watt, or whatsoever, I will not recommend anything right now because honestly, there is nothing written regarding the standard.
Okay. Next question. Is the 100 cable bundle test with all 4 pairs energized and overkill, or is this ever a realistic scenario?
That's a very good question. Many cable manufacturers have come up with different types of cable. So 100 cables, 30 cables. UL works with a 192 cables bundle. We think that the 100 cables is a typical number. I don't say it's the perfect number, but I think it will be the typical number that you can see for a category cable deployment. So, yeah, I think it's one of the worst case scenario you can see.
Okay. Next question. Sure. Power efficiency is an interesting way to look at this. Will standards in IEEE or TIA define this in the future? I don't think so. I don't think the standards will define this parameter of power efficiency. I agree it's a very interesting and actually very important parameter for our customer. We know that reducing the operating cost and reducing the energy loss are very important from an environmental point of view. I don't think that these standards will work on that right now. I think that's a responsibility. This is a responsibility of the cable manufacturer and also the installers and also the connector partners to educate the people who deploy a 4-pair power over Ethernet, and to let them know that this parameter of power efficiency is very important. It's critical for the installation. I think that's our responsibility as cable manufacturers. Okay, thank you. Next question. In summary, is it a good starting solution for power over communications cable to specify Cat6A cables for future proofing?
Actually, yes and no. I would say it depends on your application. If you install LED lightings on smart ceilings, you don't need a Cat6A. You don't need a 10G performance cable to do that. 1G, such as Cat5e, but a 1G cable is perfectly fine. So if you use a Cat5e 1G cable with a 22 gauge, you combine both things, such as the perfect data rate on your cable, which is dedicated and suitable for your application, and also better power efficiency. If you are talking about a hotspot for Wi-Fi or higher communication device, which needs up to 10G data rate. So you will need a Cat6A cable with a 22 gauge to guarantee also the power efficiency. So it really depends of your application. But I see where the question is coming from, because people, we know that typically in the industry, due to the electrical transmission performance, Cat6A cables has a larger gauge than a Cat5 cables. But I think we need to approach that a different way with PoE. We need to approach it to look at what is your PoE application and to select the right cable for your PoE application, keeping in mind what is your transmission performance that you need, 1G, 10G, and do you need to guarantee the power efficiency, so do you need 22 gauge?
Okay, thank you.
Thank you.
Next, can you comment on how likely the installed base of polyethylene insulated CMP 4-pair Cat5e 24 AWG is to see those 60 and 120 degree temperatures? I'm not sure to understand the question. Can you repeat the question? I'm sorry. Yes, I will. Can you comment on how likely the installed base of PE, I'm assuming that's polyethylene insulated CMP, 4-pair Cat5e, 24 AWG is? How likely is it that those cables will see a 60 and 120 degree temperature?
It depends on the kind of installation. It's difficult. I don't have data on that actually right now, but difficult to make a comment on that. It's probably that to see higher temperatures than 60 degrees if you're on the power over, if this cable is deployed for power over Ethernet. How the polyethylene will react, it depends on the how we call that, the thermal stabilizer that can be added to the polyethylene. It's difficult to answer precisely this question right now.
Okay, thank you. Next, could you address the options or benefits of providing a full shield as compared to an intermittent shield spread across the cable length?
And actually, that's a very good question. We looked at that, and we didn't see any main difference between fully continuous shield and discontinuous shield regarding the heat dissipation or regarding the temperature rise of the cable. Actually, the difference is so small regarding the cut or the segmentation of the shield that there is no impact on the performance of the cable regarding temperature and power efficiency.
Okay, thank you. Next question. Have you done testing with Hdpe insulation, and if so, what was the result?
Yes, we did actually. It's not in this presentation because it will be too long, but yes, we did some study on Hdpe cables. And for the cables that we know, we haven't seen any severe degradation. But again, it depends also of the stabilization, thermal stabilization of the Hdpe. We focused on the flame retardant polyolefin compound because we know that the addition of the flame retardant to the polyolefin can we had some doubt that they can severely impact the degradation of the insulation, and that's why we focus on that.
Okay, thank you. Next question. Should the cable industry focus on the development of Cat7 and Cat8 right now?
I don't know. If it's regarding PoE, again, as I replied to one of the questions earlier, if you have a Cat7A or Cat8 40 gigabyte application, yes, you need it. If not, there's no really a need. I think it's again, we need to look at the applications. Look at the application. What is needed regarding applications. So far as I know, there is no Cat 7, Cat 7A, or Category 8 POE active components available or in development. So I don't really see the need for now. But maybe in the future for data center, and I haven't looked at that a little bit. Actually, for data center, the Cat 8 would be perfectly fine to support PoE. The Cat 8 is a 22 gauge, fully shielded on each pair. Most of the designers are like this. So it will be a perfectly suitable to support 4-pair over Ethernet. But again, it's not the first attempt of Cat 8. So the first attempt of Cat 8 is to carry 40 gigabyte signal over 30 meters for very specific applications such as data center. But it will be perfectly fine to be used with a 4-pair power over Ethernet 100 watts.
Okay, very good. I am seeing no further questions, so I would like to thank you again, Thibaut, for presenting this very interesting and important topic today.
Thank you so much.
You're very welcome. Please note the contact points being shown should you wish to contact Thibaut after today's event. Each of these IWCS webinar series presentation events are recorded and will be archived on the IWCS.org website. It normally takes up to 2 weeks for these to be posted. The IWCS webinar series will conduct presentation events on a monthly basis. Webinar events will take place on the third Friday of each month at 10:30 a.m. Eastern USA time. Our next scheduled webinar event will be on Friday, December 15th at 10:30 a.m. Eastern USA time. Each of you will be receiving an announcement for the event a few weeks prior. Please feel free to share our announcements with your colleagues so that they can join in and register as well. For over 66 years, the IWCS International Cable and Connectivity Symposium has been the recognized leader, showcasing new technologies in cable and connectivity products, processes, and applications. Our next annual international conference will take place on Sunday, October 14th through Wednesday, October 17th, 2018 at the Rhode Island Convention Center in Providence, Rhode Island, USA. In addition, the second annual regional UL and IWCS China 2018 Cable and Connectivity Symposium will take place on Tuesday, March 20th through Thursday, March 22nd, 2018 at the Shanghai International Convention Center in Pudong, China. Please visit our website at IWCS.org for more event details. In just a moment, you will see a brief survey so that you can provide us your feedback and comments on today's event so that we can further improve this webinar series for you. Thank you for participating, and this concludes today's event.
Well, ladies and gentlemen, that does conclude today's webinar. You may now disconnect your lines.